Welcome back, my dear friends. A very good morning, good afternoon and good evening to all of you. And as you know, this is the NPTEL MOOC lecture series, which is spread over 12 weeks, 60 lectures, and the topic is multi-criteria decision making. And we are in the last set of lectures, and we are still 2 left to wrap up this course. And as you know, in this course, each week we had 5 lectures, each lecture being for half an hour, and after each 5 lecture we had assignments of 10 questions each, and there would be a final examination covering the whole set of topics for multi-criteria decision making. My good name is Raghunandan Sengupta from the IME department at IIT Kanpur, and if you remember, I will just highlight the important points. We have covered in depth multi-objective methodologies, different methods, non-parametric methods, different methods, univariate utility theory, multivariate utility theory, but just very fleetingly. And under non-parametric methods, Electra, Epsilon Electra, Topsis, Y-core, AHP, DA, and in the last lecture we started the decision tree. Now, for the last lecture and this lecture, as the diagrams cannot be made in Excel sheet, hence I am using the Word document. So, the general caption for all the lectures which you used to see that we are in this lecture covering this set of points, that coverage would definitely be there when the slides are shared with you. But for here to maintain continuity and without erasing whatever small calculation I am doing, please excuse me, I am continuing in the same format. Now, if you remember in the problem for the decision tree, we were at the point D2. D2 the value was 194, I am not reading the decimal, 194 minus 150, which is 44 to be compared with 0. So, 44 was positive, we will take that. When we want to find out the value of C1, now for C1 remember this, now the logic would have become clear to you. The value for high demand probability was 0.7, the value was 44.2. As I said, I will not be reading the decimal, but it is 0.2. So, 0.7 into 44.2, and for the low demand where you will stop, the probability is 0.3. So, 0.3 multiplied by 0a. So, total value, the expected mean value at C1 comes out to be 30.9. So, it is still positive. So, when I come to which is here, which is C1, now there was an investment of 20 million for the pilot plant and test marketing. So, if I consider that value 30.9, consider is 31, 31 minus 20 is 10.9, it is still positive. Hence, the decision tree would be to set up the plant, and the path to be taken are, which I will highlight here, are as follows, which means the company, I am putting a hash for the other diagram too, because as a complicated diagram in the second example, it will be colored. So, for the Spectrum company, it will build up test marketing, then there is a high demand obviously with 0.7, then it will build the actual plant at 150, and the expected value either is 30 million for 1 year, for 20 years, for a high demand of 60% or low demand on 40%, whichever it is, the thing would be true. So, it will take the path as given. So, if you see, we are solving from the right, but the overall diagram would be given. Now, the problem is, and the question which I did pose to you is that can we consider any other set of criteria to evaluate? Yes, we can use the concept of variance and try to basically find out whether variability can be utilized in order to rank them, or any other measures. Now, immediately when I say any other measures, even though not very evident, the idea should immediately ring some bell in your mind. In the DA method, if you remember what we did, we were trying to find out the efficiency. And the word efficiency was the ratio of the bundle of outputs divided by the bundle of inputs, depending on which model you are going to use. If you remember, we had the decreasing return to scale, increasing return to scale and constant return to scale. And in another case, we for the efficiency, we maximize the efficiency. And in the case when we want to take the ratio of the input to the output, we took minimization of that. So, whichever direction you are looking, it is basically the efficiency we are considering. Now, obviously, in the concept of expected value and variance, no such term as efficiency can be coined, but we can also consider the ratio of expected value to variance and consider it as one of the main way or criteria of trying to basically rank the decisions or the paths accordingly, such that we will take maximum value of the expected value to variance and rank them from the highest to lowest, or else we can take the ratio of variance to expected value and rank them from the lowest to the highest. So, it is again I am saying it is not efficiency, but it is the way of trying to analyze the problem accordingly. So, the problem which we did for expected value can also be looked from the point of view of variance, ratio of expected value to variance, ratio of variance to expected value, and all the ways can be done. Now comes the second problem, and here the second problem is a little bit more intuitive, much more involved. And here till now, for the first problem, the probabilities are given very straightforward, no complication. Here the probabilities will be given, but with a twist such that you will understand that depending on one process, how the probability would be decided for the next stage. An oil company, while evaluating the oil basin, is considering three alternatives, which are drill, conduct seismic test before at a cost of 20,000 and find the nature of the underlying oil basin, and finally do nothing. So, the company can have three alternatives of course of action, which are it can drill directly, it can conduct seismic test before, which costs about 20,000, and another thing can be do nothing. Now, the question would immediately be, when it drills, obviously there is a cost. So, cannot this cost be incorporated in both alternative 1 and 2? Yes, it can be. I have not considered that in order to make things simple. If the company drills, then it is likely to find the oil basin of three types: it is dry, wet or soaking. A dry well yields nothing, because totally dry, which means that probability or the chance or the quantity of finding oil is almost 0. If it is wet, it provides moderate quantity of oil, and if it is soaking, it will generate substantial quantity of oil. If the oil company had conducted seismic tests, obviously seismic test would give a lot of information about the rock layers, how permeable they are, how hard they are, what type of rocks they are. Depending on that, sedimentary rocks, permeability is there, whether they have a long of history where oil can be found out at greater depths. So, those concepts of tests results would basically give a lot of information for the company. So, let me continue reading it. If the oil company conducts seismic test, then it can learn about the underlying structure of the oil basin before deciding whether to drill or not to drill. The underlying oil basin structure may be, depending on the test, it can be found out there is no structure, there is an open structure and there is closed structure. If no structure is found, then the prospect of finding oil is bleak. If an open structure is discovered, then the prospect of finding oil is fair, while finally, if the structure is closed, then the prospect of finding oil is bright. So, we already know the structures are no open closed, and we already know the wells are dry, wet, soaking. So, obviously, it will mean that these combinations of doing some test and what is the actual drill results would give you different types of combination, which is very interesting to analyze. The company also knows the following, and this is what the information is given stage by stage. And please mark the values, because when we come to the solution, all those values would be important. By the way, when you are solving the problems, trying to read, the slides would be all there with you. So, please look at the slides accordingly. The probabilities of various oil bearing states are: it is dry, probability is 0.5, wet 0.2, soaking 0.2. If you sum it up, the total value comes out to be 1, as it should be. Probabilities of various soil geological states are as follows: no structure 0.4, open structure 0.3, closed structure 0.3. Again the probability comes out to sum comes to be 1. So, these are two different things: probabilities of various oil bearing states, dry, wet, soaking, and what is the structure: open, no structure, open structure, closed structure. So, one is for the drilling part, one is for the testing part. Also, we have the following joint probability distribution based on this information, which would be interesting to note. Also, we have the following joint probability distribution between underlying geological structure and oil bearing state. Now, by the way, if you remember, I said that all the values will be important. So, please remember these values. Again I am repeating, this P is basically probability, which you should be aware by this time as we continue doing the problem. So, state of dry 0.5, state of wet 0.25, state of soaking 0.25, these are the probabilities. Again the probabilities for no structure 0.4, open structure 0.3, closed structure 0.3. So, note them down as we continue discussing the joint probability overall table. And here is the table, and this is interesting. So, if you see, I have made different coloring schemes. The vertical ones, which is basically denotes the underlying geological structure, which are no structure, open structure, closed structure, are blue in color, the vertical part, and the oil bearing states, which are horizontal and they are dry, wet, soaking, are shown in pink in color. Now, what is interesting, if you do know, if we have noted down few minutes back, I said note down the values of 0.4, 0.3, 0.3, 0.5, 0.2, 0.2. These are the marginal values. What are the margin values? If you see at the right in the table, the right column and the bottom row, they will give you the marginal values at the margins. So, the marginal probability of the states of the oil bearing states, if you see, they were given as 0.5, 0.25, 0.25, and marginal probabilities for the geological structure were given as 0.4, 0.3, 0.3. Interestingly, sum up of all these three values 0.5, 0.25, 0.25 is 1, sum of 0.4, 0.3, 0.3 is 1. Also interestingly, the values which are given here, like say for example 0.32, what it means? It means the oil bearing state is dry and there is no structure and the probability is 0.32. If I continue along the horizontal row, it is dry with open structure 0.15, it is dry with closed structure, it is 0.03. If you add up 0.32, 0.15, 0.03, the total value comes out to be 0.5 as it is along the margin. Similarly, for the row wet, the corresponding probabilities for no structure, open structure, closed structures are 0.04, 0.10, 0.11 and the total sum is 0.25. For the last row soaking oil bearing state, the corresponding probabilities for no structure, open structure, closed structure, the values are 0.04, 0.05, 0.16, the total value sum is 0.25. If I follow the same logic along the vertical, for no structure with oil bearing state as dry, wet, soaking, the probabilities are 0.32, 0.04, 0.04, the total sum is 0.4. Similarly, for open structure, oil bearing states being 3 as they are written, the probabilities are 0.15, 0.10, 0.05, sum is 0.3. Finally, for closed structure, the probabilities are 0.03, 0.11, 0.16, the sum is 0.3. So, this would basically give you all the information which is needed and we will utilize that for the problem. Finally, the oil company has the following set of information apart from the condition probability table, which is regarding the net present value of the 3 states, which is net present value for the dry state is given as minus 0.6 million, which is negative. Net present value of the wet state is plus 0.8 million, and for the net present value for the soaking state is plus 2.4 million. Because as you know, for dry state, wet state and soaking state, the probabilities of finding oil was least, then medium and the highest. Now, let us go to the solution, and before I go to the solution, even though nothing is written here, let us see the diagram. Now, this diagram I have to scroll up and down, so please bear with me. As I said, the diagram which I tried drawing, considering there are so many states, decision forks, chance forks, it was difficult, but I tried my level best to give the idea. Again, the coloring scheme remains the same. Blue means positive input, some value, red means something going out, negative. Again, the same concept, we start from the left hand side, go on to the right hand side to draw the diagram, whole set of gamut of all the options, the fork and the chance, and we calculate from the right to the left and follow the path which gives us the maximum value based on the criteria which you are trying to maximize or minimize. Now, diagram is like follows. So, we start at D1 and then consider the concept. So, D11, which is the arm which is going up, is basically you drill without the test. D12 you conduct the test, and if you remember, there was a price of 20,000 which is given as red color 0.02, and the other arm which is basically here shown here is D13 is that do nothing. So, obviously, that was also an option. Now, when you drill it, what are the so obviously you do not have any idea about the structure, you immediately drill it and find out the characteristics as dry, wet, soaking. The chance fork is C11 as you are starting from there for the first one which is dry, then C12 for wet and C13 for soaking. So, the chance fork which is at the top where the mouse is hovering is given by the number C1. And what are the net present value? If you remember, net present value for the dry was minus 0.6 which is shown in red color, plus 0.8 which is shown in blue color, plus 2.4 which is shown in blue color. What are the probabilities? Dry has a probability of 1 by 2 which is 50%, wet has a probability of 1 by 4 which is 25%, and soaking has a probability 1 by 4 which is 25%. So, these values are the marginal values. Now, the question will come up, why did I take the marginal value? Because here no test has been conducted. So, these probabilities are unconditional based on the drilling only. So, there is no conditional fact added to this. Now, if I consider the, again I am saying the diagram, I am scrolling up and down. So, when you see the video and also refer to the diagram, it will be much easier for you. When you conduct the test, what three things occur? One is you find no structure which I am highlighting, and this is given by C21. Why C21? Because the arm which you reach, the chance constant, the point which you reach after conducting the test is given by the point C2. So, C21 is basically no structure. Then you have C22 which is given as open structure, which is given here. I am just made it here such that there is no confusion, and the last point is basically C23 is closed structure. Now, very interestingly, the probabilities are given. Probabilities are again the probabilities for the unconditional part for conducting at the test, because you conduct the test and then only you drill in this case. So, conducting the test probabilities were 40%, 30%, 30%, here they are 4 by 10 for no structure, 3 by 10 for open structure, again 3 by 10 for the closed structure, which is probabilities of C21 4 by 10, probability of C22 3 by 10, probability of C23 3 by 10. Now, when the no structure is found, then you drill. Once you drill, obviously you will find out as dry, wet, soaking. Similarly, when you find out open structure, again you will drill, you you will find a dry wet soaking, and when finally the third case of closed structure, again you will do it as drill and then dry wet soaking. These have been incorporated. Where? Now, if you see no structure and drill, the decision fork or decision arm or decision point is D2, and the corresponding directions it can move is basically moves to C3 and the other arm goes to D22, that means you do not drill. So, basically D21 is drilling and the outcomes are dry wet soaking, and the net present value we have kept as fixed, whether you conduct the test then drill or you only drill. The net present values are for dry wet soaking are negative 0.6, positive 0.8, positive 2.4. And interestingly, the corresponding arms are mentioned as C31, C32, C33, which is for dry wet soaking, and the probabilities are different. Now, how they are different? If you see, these dry states have been encountered after the drilling, and when was the drilling considered? When there was no structure. That means, if I go to the no structure part, and if I consider the concept of drilling, so what it would be? With no structure, if I consider this column, the total probability is 0.4. For no structure, dry being 0.32, so and hence the conditional probability would be 0.32 by 0.4. Similarly, when I go to no structure wet, the conditional probability will be 0.04 by 0.4, and finally, for no structure with soaking oil bearing state, the case is 0.04 by 0.4. So, if I consider the values, it is 0.32 by 0.4, 0.04 by 0.4, 0.04 by 0.4, and here the values are 0.04 by 0.4 comes out to 1 by 10, 0.04 by 0.4 for the third, which is soaking, comes out to be 0.1 by 10, and for the case when it is 0.32 by 0.4, it comes out to be 4 by 5. Similarly, there is a arm D22 which is do not drill, which you have already mentioned, and following this logic, if I go to open structure, which is D3, and then you drill D31, other part is D32 which you do not drill. After you drill, again you count out the same thing, dry wet soaking, net present value being negative 0.6, positive 0.8, positive 2.4, and the corresponding probabilities are, now we go to the open structure. Open structure is the second column. The corresponding probabilities are for dry wet soaking, condition probabilities are 0.15 by 0.3, 0.10 by 0.3, and the last one is 0.05 by 0.3. So, if I go to the open structure dry wet soaking, the values are here, half, 1/3, 1/6. So, if I consider half is here, 0.5, 0.15 by 0.3 is half, 0.1 by 0.3 is 1 by 3. So, you see the value of 1 by 3 here, and the last value 1 by 6. So, if I see the value of 0.05 by 0.3 is 1 by 6. So, obviously, for this case when there is open structure, D32 would be do not drill. Obviously, you have to have a do not drill in order to basically find it out. And finally, for the closed structure, with D4 there is D42 do not drill, and with D41 where there is a drill, again you have dry wet soaking, net present value again I am assuming simplistically as minus 0.6 plus 0.8 plus 2.4, hence minus 0.6 is red in color, plus 0.8 is in blue in color, plus 2.4 is in blue in color, and the corresponding probabilities are given, which I will go back to verify. This is 1 by 10, 11 by 30, 16 by 30. From where do we get? We get it from the open structure, did I do anything wrong? No, we get it from the closed structure, sorry, we are in the last term. In the closed structure, the probabilities are 0.03 by 0.3, 0.11 by 0.3, 0.16 by 0.3. So, if I go 0.03 by 0.3 comes out to be 1 by 10 and the corresponding values of 11 by 30, 16 by 30 are for the last two values. So, once you have that, the total diagram is done. Now, I need to do the calculations from the right to the left, and here is where we will again try to find out. For the first case, we will basically for this arm, we will multiply the probabilities with the net present value. So, probability of 4 by 5 into 0.6, and remember I am showing it. So, obviously 0.6 will be negative because a negative value, plus 1 by 10 into 0.8, 0.8 is positive, plus 1 by 10 by 2.4, 2.4 is positive. So, based on this value you compare with D22 which is 0. Then you calculate the values of this D3 1 root, which is 1 by 2 into minus 0.6 plus 1 by 3 into plus 0.8 plus 1 by 6 into plus 2.4, you compare with D32. And finally, for the case where you have the closed structure, when you want to find out D41, you find out 1 by 10 into minus 0.6 plus 11 by 30 into plus 0.8 plus 16 by 30 into plus 2.4, you compare with D42. So, once you have compared, then when you reach D2, D3 and D4, the values will be found out. So, if they are negative, then obviously you will take the negative value or you will take the value 0. Why 0? If you remember, in utility theory I did discuss, we can consider the values if they are negative as 0. So, once you reach D2, D3, D4, the corresponding values which you will multiply for D2 would be 4 by 10, because that is the no structure probability. For D3 it will be 3 by 10 and D4 it will be 3 by 10. And correspondingly, once the overall value is found out for C2, remember that 20,000 value is there, that has to be incorporated and the problem solved accordingly. Similarly, the variance can also be brought in the picture, the ratio of variance to expected value can also be brought into the picture, the ratio of, say for example, expected value to variance can also be brought into the picture and the problem solved accordingly. So, with this I will end this class. We have discussed in detail two problems in decision trees. I have solved in detail about expected value, it can be extended for other criteria also. The slides would be shared with you. I will not say the slides, they are the Word document will be shared with you. When you see the lectures, please refer to the diagram. There can be variety of problems, but once you get the hang over of this flow of how the problem can be solved, you can solve it accordingly. But remember, from left to right the diagrams are drawn. The chance folks C and D, their C and D are not the concordance or discordance. Probabilities are to be considered, conditional probabilities are to be considered, net present values have to be considered, provided is expected value. In other case, you can consider the variance also. So, with the again I am saying I am ending this class in decision trees and discuss a simple problem for the last set of lecture for this whole course. Thank you very much and have a nice day.